What is the definition of a volume, by the way? Suppose
Yes.
this is the bottom, I say this is B1, and
Okay.
and this is the corresponding to B1, the corresponding parallel region having same size as B1 but corresponding to
Okay.
this. So both B1 and B2 are same, but they are adjacent to each other. And B1 and B2, they are the boundary, from this whole boundary they are connected with each other. This is a kind of a cylinder. And for example, if you are connecting, say for example, you are connecting this point of the B1 to this point of B2 from exactly the same location on both, then this line is a vertical line, and this line always have 90-degree angle with B1, and also it will have 90-degree angle with B2. Do you understand? It will be like this.
Yes.
If this is the upper portion, the line is connected like this, so the angle between them is 90. Similarly, go back to the bottom one. From the bottom, the line is connected like this. So all the boundary is actually a combination of the lines which are connecting the boundary like this. Similarly, from that side, it will be connecting from there, this to this. So every line, they have the angle 90-degree with the bottom and the upper surface, but that side is cut down. So it is actually not a perfect circle, but one side of this is a rectangular.
It's a half circle.
Yeah.
It's a half of a cylinder.
You can cut the half of a cylinder. So this is just like that.
Right.
Now, if I say that A is the area of base 1, B1, and this distance, the distance between B1 and B2, this is height. So I'm saying that the distance between B1 and B2 for every line, all the lines, they have the same distance. That's why it is the perfectly placed, the B1 and B2. So this distance is h. Then the volume of this shape is given by the area of the base, or whatever the cross section you pick up. From wherever you will pick up, this area will be same. Whatever, for example, if you cut this whole cylinder into small slices, just like if you pick up a bread or any shape, anything like this, and you cut the slices, then every slice will have the same
height.
Will have this, the base, the cross section will be the same. So this area of this whole region will be same from here to here. This shape, this D. Wherever you cut, whether you cut it from here, H1, from here, wherever you cut, this shape will have the same, you can say the area. So that is the area of the base. If this is the area of the base 1, then of course base 2, every single slab. If you cut it, I said this is B1 and this is B2. You cut them into many slices and it become B1, B2, B3, B4. Every B will have area A and the height h. So this is the volume of this kind of a shape. Similarly, if you have a perfect circular shape, and this kind of a scenario is called a cylinder. So if you have the same shape but in terms of a perfect circular like this, then what will be the volume? Any idea?
What? Can you ask again?
What will be the volume of this shape?
So we will find the area and then multiply with
what is the area of a circle?
Pi r square.
Yes. So the area is pi r square, and I know this is height.
to height.
So the volume will be pi r square h. And if I have a cylinder of this shape,
Then pi r square h. Okay.
like
Asking something else.
like if you make a shape like this, how to make, yeah,
Square.
a rectangle box. Am I right?
Okay.
Yes. This and this.
Okay. Okay.
So if you have this kind of a rectangular box, then what will be the volume?
The area into height, and the area will be the width into length.
Yes, width into length and the height. So if you have a rectangular box, the volume will be this. If you have a circular box, complete circle, then simple change is, this was the circle we have cut down. So I don't know how much I cut down. That is why I simply wrote A. I didn't wrote half pi r square.
It's not half. We don't know if it's half.
Yeah, we don't know it is half or 1/4 or 1/3, whatever. So that's why we said A.
Right.
So you can decide if it is half, then it will become 1/2 pi r square into h. But and this was
Right.
for the full, and this is like for the rectangular shape. So all these
Right.
shapes, they are cylindrical shapes. Now for these, we know the perfect formulas to calculate the volume. So this is okay for us. There is no need of integration. What is the problem then?
Yes.
Why do we need integral to calculate volume? What is the problem?
Maybe because we don't know the area. We don't know exactly the area.
Whenever you have these kind of shapes, you know the formula. Either it will be area into h, it will be pi r square into h, it will be length, width, height. So you always have the opportunity. If you don't know the area, you can calculate the area. You know the methods. If you don't know any of the value, you can calculate. And we have done these things in Advanced Mathematics 1 for some practical applications.
Okay.
So we have no problem with this kind of shapes. The problem appears when we don't have this kind of a shape. For example, this side is showing the whole scenario. What kind of shape is this? This is the cut piece.
Okay.
For example, we have cut down the piece from the top edge. If for example you have a cream roll and cut the top edge of the cream roll, now this is showing what is the shape going onward. So the whole shape is like this, a cavity, a irregular shape, and the size will change. For example, here it is smaller, here it will be bigger, here it will be, and again it will be smaller, but the shape will continue like this. So if we need to calculate the volume for this kind of a shape, then we don't have a formula like we have the formula to calculate those regular shapes. Well, then what should we do? You already know how to deal with such problems.
We'll take integral. Use it in integral.
If you recall, area under the curve, we had an irregular boundary on the upper part.
Yes.
And we knew that how to find the dimensions for the rectangle. If we have a rectangle, we can find the area, but we never know how to find this irregular shape. So what we did, we cut this into small slices, and we said, yes, if I assume that any one of these small slices are looking like rectangle, then we can calculate the area. Similar to this, if I anywhere in between, say for example in the ith portion, the shape will be going like this. Suppose if I cut this piece, and it will definitely be coming like this. in between. This is, I'm saying, this is the ith slice of this whole cream roll, just like this. Okay, at the moment, if you are confused in it, we can stay up to here. Forget about it. If I cut, now this is the shape, and if I take this part, a small width of the piece, and I cut this part of this bread, if I cut it from here, then I will get this piece of the slice. So if I cut it, the piece of the slice will be like this, right?
Yes.
Now it is just like the piece of the bread. If you cut the whole bread into a small slices, then this is just like a slice of the bread. But in case of bread, the shape of mostly breads is rectangular, so they are different. That's why we are talking about the cream roll, because it is a circular irregular type. In case of bread, the case is very simple. So this is just like a slice of the bread. So what we do, we cut down this whole shape similar to the area under the curve into small slices. Now I know how to calculate the volume of this kind of a shape, because if I put this shape just like this on the ground, like this, it is placed on the ground, then this is what? This is the height of this slice.
Okay.
And
Okay.
this region is actually that B1, if you recall.
Yes.
That part.
Yes.
So I know how to calculate the area of this region, and I know what is the height. The height will be my small delta x. When I multiply delta x with area, I will get the volume.
But here we don't know the B2, right? We can just simply multiply height with B1.
No, this you know this dimension, but you don't know the irregularity. When you cut the slice into it, now you can calculate this area. This is just like the area of this shape. So this is the base. You calculate this base, because we needed one vertical side, and we have got that one vertical side. So we will assume.
My question is, we don't need the B2, right? We only need B1.
No.
And the height.
You see, B1 and B2 are equivalent. This bread is placed on the table. So the side touching the table is B1.
Yes.
And the side on the face is B2. Upper side is B2. Lower side
we still
is
need, okay,
B1. They are equal. No matter, that doesn't matter. We will solve an example, and you will see how it works. The problem is we needed a height, and we have cut down. Now similar, just stick to it. Stick to like this. The smaller you will cut down the pieces, the correct volume of this whole shape you will get. The larger you will cut down the pieces, the larger you will keep this height, this region, the more will be the error in calculating the volume. Just keep this concept in mind, and we will develop the formula for it. Now, okay, let us keep that thing, and we do some mathematics here. The same shape, and I'm saying that I'm going to cut down. Okay, let me draw the coordinates. This is the x-axis, this is the y-axis, and I know these two are the boundaries of this whole shape. So this is my point A, and this is my point B, right? Because this is the total boundary of this shape. In between A and B, I have to figure out the volume. Now I'm assuming, suppose anywhere there is a point X, and I pick up this whole, suppose this is the cream roll, and I pick up a small rectangular plane. This is a plane, or you can assume a knife, and I cut this piece like this. So I'm going to draw this plane here, just like a knife. Do you understand this? When you cut this is the cream roll and you are going to cut it with knife. So the surface of the knife I am going to draw there. So the surface of the knife will be like, for example, any blade, anything like this. And it is like there. And it crosses, okay, let me have the X here so that it can touch. It crosses this point. This is X. So this is actually the knife when you cut the bread. And the knife has cut it one part, one slice here, it is passing through there, and I am naming this guy as AX, the plane AX. Oh, sorry, PX, because it is plane.
You also need to calculate for the knife.
So we will assume that the knife is, that you know, a very famous meme. They say that when we calculate the pizza volume, there is always a point something difference, and or you cut the cake and you calculate mathematically the whole volume of the cake, you will get some difference. And the person said that yes, that small difference of the cake is on your knife, which you don't consider it. So we will assume that that knife is just like a zero. Just similar to that, yesterday, the day before, the last week we were doing an example and we said that the car takes a U-turn, and we assumed that there was no distance in the U-turn, although there was some distance in the points. So we cut this bread into the pieces like this, and we pick up that slice similar to the size of the bread, and we say that this has the area A of X. Then this shape is represented by the area A of X, and if you cut, for example, this one is the first part of the cut, and you cut, so you got this face, one face of the slice, and when you apply the knife again, you apply the knife to get the second cut, second part, side of the slice. Of course, when you will cut the bread, you need to cut it 2 times to get one slice, right? If you want to get the bread in between, for example, in the middle of a bread, this is the total bread, and from the middle I want to get a slice, I need to cut it 2 times to get that slice.
Yes.
So it's the same here. One plane cutting this time, and I say this is the ith cut, and one plane again cutting this time, and we say that that one is I minus 1th cut.
Okay.
Right?
Okay.
So if we do that, and I assume that the point, just keep this thing in mind, and this is not difficult, only the shape is creating problem. And I assume that if I steric is the middle point of these two guys, xi minus 1 and xi, midpoint. If this is the midpoint of these two guys, then the area of this slice, this shape, area will be A of xi steric. Area you can calculate using this formula, and the slice will have this width. This width will be delta x. So I am assuming I am saying this is the ith slice from the whole bread, and for this ith slice, the cross sectional area will be calculated by this, and the width is actually the height when you place the slice on the ground, just like that shape. When you place it on the ground just like this, so you are placing the bread rest position just like this, then the bottom is touching the table, upper surface is upward, and this is the height of the bread, which is actually the small distance which you kept when you cut down the pieces, cut down the two pieces. So that small distance is actually become delta x, and this is actually what? This is the height. This is the height of the slice, and this is the area of the slice, the B1, B2 surfaces. So this is what? This is the volume of the ith slice. This is the volume of one slice which I have cut down from the total bread. Now, when I need to know the volume of the whole bread, I know what to do. I have got volume of the one slice, ith slice, and the volume of ith slice is AXI steric into delta x. Then what will be the volume of the whole slice, whole region S? This whole is S. The volume of whole will be sum of all the slices from 1 to n. All slices. I have cut down this whole thing into n number of slices, just like this, from 1 to n. So when I cut down this whole bread into n number of slices, it becomes summation I from 1 to n, area of each slice into the width delta x, and I will cut down all the slices equally. Look, this is the tomato. Assume this is the bread. And I cut down one piece in between this tomato, just like this. This is one piece from in between.
Okay.
And now I put this slice, this is the slice of the bread, I put this slice on ground like this. So this slice is on ground like this. Now this width is actually now become the height of this slice. And this is B2, this is B1. I know
Right.
B1 and B2 are equal, so whatever the area will be, it will be same from both sides. And
Right.
this is the height. So this is the ith slice from this whole tomato, and I know that how to calculate the area and the delta x. Area is just like, in this case, it is just like the area of a circular shape. In that case, you can assume that yes, it is a circular shape when you cut down the slices into smaller pieces, and there are many other things, many other ways. So this area and this height gives me, we have followed the same formula. Volume was equal to what? Volume was equal to area into height. So the height,
Okay.
delta x, area of the ith slice. This is the volume, this is the volume of this part of the tomato. Now I need to find the volume of this whole tomato. What I will do, I know that this tomato can be cut down into n number of pieces. So I say that if I cut down this tomato into n number of pieces, then sum of all those things will give me the whole area.
Okay, right. But this one you have written the equation in the Riemann sums form, right?
Yes, so this is now actually similar to the Riemann sum, but in this case we don't have, the function is area. In that case the function was f of x delta x. This was the function. So this function was a single one dimensional function. But when you will have area, it is a different kind of a function. So, but again, area
You
is,
can write it.
area is a function because the shape is changing. So every slice will have different area.
Right.
Because somewhere it is increasing, somewhere it is decreasing. For example, this edge will have smaller area, the slice which you will cut from here. The slice which you are taking from here will have a larger area. So area is changing. That is why we need this whole thing. This is similar, and now I can link this guy with the final definition that the actual volume, total volume, will be limit if I cut down the whole bread into so tiny slices that the width approaches 0. The delta x approaches 0 means the number of slices become infinitely many. Infinitely many. So we can say that I want to n a xi steric delta x is the volume of this whole shape, and we also know that this can also be written as integral from the first point A to the ending point B. The function is now area A of x dx. This is the formula to calculate the volume of an irregular shape like this.
In the form of integration, right? And what will be the A and B in this case?
Of course, these points will be given to you, just like here. They always give you some points. They say that, okay, if we will solve an example, you will see. So A and B will always be given to you. These are the boundary points. Similarly, area.
What if we talk about only one slice?
What?
What if we talk about only one slice? Then what will be the A and B? Can we calculate?
No, you have the formula for A and B. It is you can always relate them. You know that what is the value of delta x? Delta x will be b minus a divided by n. So n is your job. You can decide what should be, how many number of slices you want to cut. But the boundary will always be given to you. If it is not given, for example, you are practically doing an example, then you can have the like the meter reader to just calculate what is the total length.
No,
So
I mean, here we are, the final equation you write for the volume, it's the volume of whole bread or roll, you can say.
yes.
Okay, and the boundary points are A and B.
Yes.
What if I want to calculate only the volume for one slice which I cut down? Then which points I will take for A and B?
So it depends which slice you are taking. If you are taking any ith slice, so it is always ith means you can do this simply. This guy is one by one if the slices number of slices are small. For example, if you want to make 10 slices, then you can talk about the area of a single slice. But if you are making 1000 slices, then you can never talk about any single slice because it will take your whole day. So for 10 slices, you will decide, okay, which slice you want to find the area, and you tell me that, okay, I want to find the fifth slice, area of the fifth slice. Then you can calculate these points according to A and B. If A and B, for example, 0
to 10, then we will divide.
If it is between 0 to 2 and you want to find the area of the fifth slice, you can calculate this point.
Right.
Show that the volume of a sphere of radius r is v is equal to 4 by 3 pi r cube. So we have to prove that volume of a sphere whose radius is r is this. Now, if he is talking about r and talking about the sphere, then consider in your mind a ball. And we are assuming that this ball is placed at the coordinate system such that the coordinate system is passing through the origin. So this is 0, 0. Means this is the center of the ball and the coordinate system is crossing the center of the ball. Right? Just assume like this. This is a whole ball, a circular ball shape. And you have in the middle of the ball, you have crossed the vertical, the axis lines. So if this is the middle of the line, then you know the radius is r. So anywhere if you connect the middle point, this length will be r. And you can always draw a vertical line from there to the x-axis, always. So if you draw this vertical line, then this height is y.
Okay.
And if this is y, and you know that this is x, this is x-axis, this vertical line is y. So anywhere,
this shape reminds me of sandwich theorem.
Yeah, anywhere you go, this vertical part will be y, horizontal part will be x, and this is the radius. You know this. So from the Pythagoras theorem, you know that x square plus y square is equal to r square. Or you can say that what we need to do, find y. We need y, okay. So it will be y is equal to under the root r square minus x square, right? From here, you can get this. So this is one thing we needed. Now, if you focus only on one slice of this ball, such that the slice is from this point, then the slice will look like this, right? This is the shape of the slice. Forget about every other thing. This is the slice, one slice, just like a CD disc. So this is one slice of the CD disc, right? Then what is the shape of the CD disc? It is a circular, flat circular surface, right? This is a CD disc. This is not the CD disc. This is the ball. Keep both are different shapes. This is a ball. I represented it on the paper, but this has a circular ball shape. But this is a CD disc, a flat CD disc. It has a circular shape, but upside and downside are the B1 and B2. Understand? Are you listening?
Yes, yes, yes.
The upside of the CD is like this. The downside is like this. Only this is circular and there is no width, assuming delta x is small. So this is a CD, flat CD, and this is the ball. They are different. I have cut the ball from one side with anything. Now I have separated this surface from there. So this surface will look like this, and in this surface I know the values. This the height is the y, and if I want to calculate the area for this, it is simply the area of the circle, pi r square. But in this case, this distance is r. Look, I have picked up this shape here, and you know that the small part from here to here, this is called r. Half of the complete circle is the radius. So this radius is r, and I have just now find out that if in the case of the ball, the radius was here and this was y. But in the case of the one small CD, now the height is equal to the radius. This height is equal to the radius. So actually my r is equal to y now. And when I replace this r with y, I have the value of y. So I can put it there. It will become pi under the root r square minus x square. Whole square. This has square. So this will cancel the pi into root r square minus x square. Now this is the area function for this whole ball. I have using one slice, I have found the area function. Now this area function will represent the whole ball. And now
I don't understand this part, the area part. Pi y square.
Oh, pi y square, I replaced it the r. You know what is the area of a circle?
Pi r.
Pi r square. Now focus on one slice of the whole ball. On one slice of the whole ball, just consider this slice. You see the height I told you, this is the y-axis. So this is the height of the ball. So wherever you will take up the slice, that height will be y. And this height will be actually half of the down part of the CD and half of the up part of the CD. Because you are cutting the CD from the x-axis. So up and down are equal. Now if this is the up side and down, then what is this? This is radius. Also this width, this is radius. And I am saying that if this is radius and also this is the height y, because I cut down from the x-axis, So my radius is equal to the height y. So I replace this formula from r to y square. And for y square, I already got a value for y using the Pythagoras theorem for the whole ball.
Okay.
This is the value for the whole ball. This is the value for one smaller disk. So it replaced when you put this is the area function which will determine the whole volume of all the slices of all the smaller CD disks. So when you will cut down the ball, every time this function is applied to find the area for that specific slice. But we don't need to find the specific slice. We are just going to apply the integral. Now, they said that the radius is the radius of the ball, volume of a sphere of radius r. It means on the negative side, it will be minus r. On the positive side, it will be plus r, the radius. So my region is this one from the negative to positive.
It can be minus and positive
r? Because your ball is centered at the origin. This is the origin of the x-axis and y-axis. And you have placed the ball like this. So, if this is the radius in the positive direction, then this is the radius in the negative direction because this is the origin towards x-axis, towards negative x-axis. So whatever will be here to here, it is minus r. So this point is minus r. This point is plus r. So my whole shape is
boundary points.
Yes, my whole shape is in between these two boundary points. So my integral starts from negative r,
minus r,
finishes at positive r, and the area function into dx.
X.
That
dx.
is minus r to positive r. The area function is pi
into
r square minus x square into dx.
Square.
Pi is a constant. You can take it outside. One more thing. If you recall the lecture, last part of the lecture, we said that if, and yesterday I also told you that this is just like a flip of two sides, flip of the butterfly wings.
Yes.
If you cut them separately, positive r and negative r, they are equal.
Yes, same shape.
So you can say that if this is minus r to r, then it is simply 2 of 0 to r. 2 of 0 to r, it becomes the total. Or 2 of minus r to 0, both are fine. You can say minus r to 0 and the 2 times. Or 0 to r 2 times. I told you that if you have area 1,
I understand the concept, how it's working.
Yeah. So you can replace it, the dimension from negative r to r. Instead of that, you have replaced it with 2. 0 to r.
It will not affect any sign.
No, because they are same. So you can always add 2 into the area. And the pi is constant, you can take it outside. Inside it is r square minus x square dx. Since your variable is x, so you will do the calculation.
I am confused in if we take it minus r or r. When we apply limit,
no problem.
For one time we will put positive and for the other time we will put negative.
No problem.
But if it's,
I'm telling you, you can solve it similarly. No problem. No need to replace this. The answer will be same. I told you this is just a kind of a burden for you. So you just using previous knowledge to reduce the burden. Otherwise, you can solve any of the integral.
It will not affect on any.
Yes.
It will not, the signs will not.
It will not affect the answer. So it will be 2 pi r square x minus x cube by 3 because you are dealing with dx. So r square is not a variable, it is a constant. And the limits from 0 to r. When you plug these limits, it will be 2 pi r, first point, this is the r, this is the b, so it will become r cube, this r and this r square, r cube, minus r cube by 3, and the second is 0, so both will become 0. Simplify them, it will be 2 it will be same this value 4 by 3 pi r cube. So this is the volume of a shape like a ball. When you don't know the value of radius. Now if I tell you that okay, if the radius of the ball is suppose 1 meter, then you can put the radius here and you will say tell me that okay, the size of the volume of the
So
ball
we
is 4.
just made the equation and we only need
Yes,
the
this is
radius
the
and
this
then
is
we
a
will
general
put the
equation.
volume.
This is a general equation for a sphere of radius r. Now
Right.
the value of r will tell you what will be the volume of the
But it's
shape.
only for the
Sphere of
circular
radius r.
shape.
This formula is valid for a sphere of radius r,
Right.
not for any other. This is just like an example that how those
Yes.
slices work. We cut
Yes,
down
right.
one slice from the shape and we use that to find the area function, and that area function we use in the volume. That's it.